Hello world, it's Rational Pi. I'm here today to talk about structures. It's so exciting. But to do what we want to do with our MBA conferences project, we really need to start creating what's called structures. And we're going to be using C# in this example. We're going to be using C# the rest of the way. So let's go ahead and take a look at our flowchart. So in a C# document or a program, the namespace, which is like the project name, is going to be MBA conferences. Structures in C# are kind of like data structures, like int and boolean and double and things like that. But they are data structures that you create on your own. So for example, we're going to be creating the city structure, which is going to include the node number, the name of the city, the longitude, latitude, and heuristic of that node. And then there's going to be the path structure, which is the path from one node to another. It's going to include the first node, the second node, and how much the path is going to be total. So we're not going to be using the heuristic today because we're going to be utilizing that later in the A* analysis. So what we need to do first is we need to find the number of cities being tested. And in this example, I'm just going to prompt the user or myself for 5 cities. And then we're just going to test the program and see how it does with those 5 cities. Whenever I go to full scale, I'm probably just going to read it from a text file. Being able to pull from a user allows a good checks and balance whenever you're programming something. And then as I said, we're going to obtain the information using the city structure. We're going to calculate the number of paths we're going to need, and then we're going to obtain information using the path structure, and then we're going to associate each city with its appropriate path. So let's go ahead and jump right in. So these using statements at the top, these are just standard C# statements. They are going to be there every time you start a new C# document whenever you open up in Visual Studio. As I mentioned, the namespace is MBA conferences. That's just the name of the project we're doing. Class is just the main class of the program. You can have various classes that do various different topics. And then in here we have the different domains and the different things that you're working in. So what I created here was public structure city. So it's going to be a city data type. And inside that city, it's going to have an integer for a node, string for a name, and double longitude, latitude, and heuristic. Then we have our structure path, which is an integer for first node, second node, and double for path cost. So what I did is I created like an int. Like if I want to say city, Oklahoma City equals new city. And then I could give it the attributes of node of, I believe it was 9 in our example before. The name would be Oklahoma City. The longitude and the latitude would be whatever it is, and then the heuristic would be the winning percentage that we calculated before. And then if I wanted to find a path between Oklahoma City and Dallas, I would then say the first node is node 9, second node is node 10, and then the path cost is however much the cost is between the 2 nodes. So that's kind of what we've done here, and it's a very handy tool to use whenever you're needing some outside of the box structures while you're programming. Let's say you need some data that's very tightly correlated and you don't want to use arrays or lists. This is a good way to clump that information together. And you can even create arrays of your new structures, which we're going to be doing later. So that's what explains these, and then we're going to go to our main method right here. It's always got to be a static main method. Every C# code has to have a static main method. Let's see here. The number here is our number of cities that we're going to be analyzing. The path number is the number of paths. And we're going to ask the user, how many cities are we going to analyze? And then this convert to int32 means whenever a user inputs something into the console, and I'll show you that here in a second, it always comes through as a string. So you need to convert it to the proper data type that you're wanting to find. So then we're going to create an array of cities, and we're going to call it the MBA array, and it's going to be a new city array of number and values. So if we're analyzing 5 values, it'll be a 5-value array. And then what we're going to do is we're going to create a for loop, which goes from 0 to the number of cities, and then we're going to ask for the node number, the name of the city, the longitude, latitude, heuristic of each of those cities. And then one thing that you could do here to make it a little bit better is you could create checks to make sure the data type that's entered by the user is the proper data type, rather than, let's say they entered a string instead of an int and you needed an int, and then it would just error out the code. So that's a couple things you could do. I did not do that here. That will be in our final code. As you can see, there's different converts here as needed. Here you do not need a convert because the name is going to be a string and strings are automatically brought in from the console. What I did here was we need to figure out how many paths we need to define. So what I did was we don't need 29 paths for every one city. If we just calculated the paths for half of that, let's say, we wouldn't need to calculate the path from 1 to 30 and then calculate the path from 30 to 1 because it would be the same. So what I did was we needed to find the appropriate number of paths we would need, so I figured it out to be the summation of 29 plus 28 plus 27 all the way down to 1. So that's what it's going to end up being, and that's what I did here. So every time the for loop does a loop around, it's going to add the counter to the previous path number value, and it's going to create that value that we need, and it's going to give us the accurate amount of paths we're going to need to do this. And then we made a NBA paths array. That way we know all of the first node, second node, and path values for all of the paths we're going to need. Like for example, if we have 4 cities, every city is going to need at least 3 paths to go to every other city. So we're going to have a total of 12 cities. So then we're going to create this first latitude value, second latitude value, first longitude value, second longitude value, and that's going to be used in our mathematics later. Then we're going to create a new for loop that's going to allow us to input the data for the paths, and it's going to just be based on how many path numbers there are. We're going to ask for the first node, we're going to ask for the second node, and then for the path number, what we did here was for every city, we're going to compare the node. If the node that we input is in the node value structure for the NBA array, then we need to find the longitude and latitude of that node. And then for the second node, we do the same thing. We find the longitude and latitude of the next node. And that's what the first long, second lat, second long is. And then once we have both of those values, we can use the Pythagorean Theorem, math, where it's the square root of the longitude from the first one minus the longitude of the second one squared plus the latitude of the first one minus the latitude of the second one squared. And then the whole thing is the square root. In C#, you have to use math.square root and then math.power, whatever you want to raise to the power, and then 2 is to square it. So that's how we're going to find our path cost for each one. Let me zoom out here. And so then we're going to print out from node blank to node blank has the cost of path cost. Okay, pretty simple stuff so far. Alright, so whenever you see this in C#, that means you're going to have a multi-dimensional array. You can have one-dimensional array, which is a list of numbers. In multi-dimensional array, you'll have an index, and then you'll have a list regarding the index, and the next index has its own list. Next index has its own list. And that's what we're going to do here. That's how we're going to associate the cities with their appropriate path costs. And then we're going to associate all of the paths that this one node can take. So M is going to represent our cities, N is going to represent our path numbers, and then we're going to just reiterate through all of our arrays that we've created and find out what paths we need to find out. So we need to figure out the first, let's say we need to figure out the first node, and then we figure out the nth path. If we find that that path or that node is in the other array, then we need to save it in the path cost based on the counter that we created here. And the counter is going to start at 0. The counter is going to increase every single time it passes through. That way we have a total of 29 paths associated with the one city every time we do this loop if we have 30 cities. And then what we do here is, just for clarification's sake, if the node that it's finding is the first node, then we need to make sure we compare it to the second node. If the node that it's finding is in the second node, then we need to compare it to the first node. And then we just say the name of the city is this far away from node blank. And then we reset the counter. This console.readline is just a way for me to stop the program and allow me to analyze what's been printed so far. So I think this is a good time to go ahead and test what we've done. No errors, no errors, no errors. Hey, it works. All right. So let's just do let's do 5 cities. Enter the node number. We'll do 1. We'll name the first city A. The city's longitude, let's do 5. Latitude 5, heuristic 5. We're not using the heuristic in this program. That's going to be added later on. The next node number is going to be 2. Name of the city is S. Longitude, let's do 10, 10, 10. Next node number 3. Name of the city is D. Longitude is 15, 15, 15, or 5, whatever. And then the next node number is going to be 4. We're going to name that one F. 20, 20, 20. And then the next one's going to be node 5. We'll name that one G. That's going to be 25, 25, 25. And this is going to ask us what the first node of the first path is we're going to calculate. So let's just start with 1, and then we'll go to node 2. So then it'll say from node 1 to node 2 has the cost of 7.07, which is the total cost between going from node 1 to node 2 based on the numbers that we found. So then we're going to do from 1 to 3, 1 to 4, 1 to 5. Then we're going to do 2 to 3, 2 to 4, 2 to 5, 3 to 4, 3 to 5, and then 4 to 5. And so now we know for sure that every path that we need has been manually entered, because we needed all of those different paths, and we didn't need to enter 5 to 4, 5 to 3. We already had those. We just needed to flip it around like we did earlier. So then we have A is node 1, and we have from 1, 2, 3, 4, 5. S is node 2, so 1, 3, 4, 5, good. D is node 3, 1, 2, 4, 5, fantastic. F is node 4, 1, 2, 3, 5, great. G is node 5, 1, 2, 3, 4. So now for every node that we were looking at, it properly has the amount of paths that we need. And this is going to be in degrees. These values here, they're in the latitude and longitude degrees. And if we wanted to, we could find a conversion for miles if we really wanted to go that route. But there's really not a reason to, because that is a good indicator of distance, considering we're comparing it to other degrees. Now, if we were comparing degrees to miles, we would want to convert it. But since this is a good indicator of how far away something is from another place, we can go ahead and use this, no problem. So we know that our code works up to this point. So what did we do in this video? We learned what structures are. We learned how to utilize them in arrays. And then we were able to manipulate them to store like data so that we can utilize that data later on. We also learned how to do multi-dimensional arrays, and this is all in C#. The C, C++, and C#, while similar, do have different ways that they utilize these different functions. It's really easy to look up. There's a lot of good websites such as Stack Overflow. I did a video over that before. Or you can just ask me below in the comments. I'll be more than happy to help you out if I can. GitHub is another fantastic place to, if you have like a larger project, they have a really good community there to really help you out. A like and subscribe is always appreciated. If you have any suggestions, comment below, and I'll see you guys in the next video.